Hello everyone, I'm gonna present the first work on how to trust OCR performance evaluation for basic vision task. This paper is published in Transaction of Pattern Analysis and Machine Intelligence in collaboration with Monash University, Curtin University, Stanford, and Adelaide. Monash is my home. Okay. Well, we are relying on the performance measures, or sometimes we call it metrics, to understand if the strategy we are working or framework we develop has improvement or not. We are relying on the benchmark to rank the methods, and then benchmark center around some performance measure. Where even for the same problem across a different benchmark, or we can have a lot of performance measure. The problem is, okay, we rely on performance measure. Who evaluate performance measure for us? So this is about how we can benchmark the metrics or performance measure. So this work, we are coming into the propose a guideline in this paper. It has a threefold. The performance measure should be reliable, should have a meaningfulness and mathematical consistency. And then for reliability, we say if the model performance measure has hyperparameters, the change of hyperparameters should not change the method rankings. Otherwise, it's not meaningful, all right? It should be mathematically consistent and satisfy the metric property like a triangle inequality. And also, the most important one, we kind of find a way to benchmark, means rank the metrics. And that's, we are proposing a sanity test instead of the computer vision application. If you are interested to know more about it, please come to the poster. All right, okay. The second one is the paper recently accepted in CVPR, GRDB pose, but I decided to just maybe talk about the data set itself because that GRDB pose is a part of the data set we annotated. This data set is, this is the kind of things we started when I was in Stanford. We had the social robot, which is equipped with lots of modern sensors, including camera, monocular stereo, LiDAR, IMU, GPS, and it's called social robot. It's called Jack Robot, and it's actually featured in the New York Times as well. So we've used this opportunity to capture a very interesting data set from a Stanford campus in lots of different places, indoor and outdoor. And over the years, we are actually start to provide more annotation for the robot to fully understand human object scenes. And good things, we bring it to the Monash. So now data is hosted in the Monash server and is a larger scale data set for kind of full understanding of human environment. And now we have about 300 active users all over the globe. We have published 3 papers on it. We run 4 workshops in top venues. And industry, like we have a user from Apple, Google, Intel, Amazon, and the academia, like a UC Berkeley, are user of this great data set. If you're interested to more about this data set, please come to our poster.
Thank you so much. Fatima?
Hi, everyone. So this research work is funded by Australian Defence and Science Group. Usually adding auxiliary modalities to natural language processing tasks recently become very popular. And for the task of event extraction, you can see in the first figure that from a piece of news text, text-only models can extract event based on the trigger word clashes. Can detect event, attacked event from the text, but from the image that comes along with this piece of news, we can see an event life die. We can see that images can introduce some salient information, so it complements the what contains in text. But the problem in the area is that there is a challenge of data scarcity. So we need a large labeled paired text images for training a model usually. So what we presented in this work is a few-shot domain adaptive visually fused event detection model that can be trained only on few labeled paired text image paired data set, and it handles the data scarcity problem, especially as you can see in the top on the right top figure. The visually we introduce a visual imaginator which can synthesize images in the absence of visual context. So it allows us an effective inference when only one modality is available during inference. So our model can outperform the state of our models. And please, if you have any question, reach out in the poster session.
Thank you so much. And the last is Graham Farth. Over to you, Graham.
Thanks. Can you hear me all right? So good, thanks. Yeah, so I like to count things in graphs, and associated with every graph is a polynomial, the Tut polynomial, that helps us do this. It contains a wide variety of information about counting structures of interest in graphs from a variety of different domains. You can think of it as an algebraic data structure, if you like, that can tell you numbers of colorings, which are used to model resource allocation timetabling, numbers of spanning trees, network reliability in communications, measuring it, some classical partition functions from statistical physics, weight enumerators from coding theory and other things. Now, graphs, ubiquitous as they are just a special case of far more general combinatorial structures that go by names like matroids, powerful sets, clutters, and most general of all, binary functions and their close relatives, quantum registers. So I'm interested in counting things for them too. And very fascinatingly to me, the Tut polynomial also extends to that level and can tell us information about counting things on those structures that was, already considered independently of interest, but I was able to put that in the framework of the Tut polynomial. So I'm interested in expanding that, expanding the range of things that these generalised Tut polynomials can do for these quantum registers, and to developing quantum algorithms in that area as well. Thank you, and see you all at the poster.
Fantastic. So that's it, actually.